All right, in this section we're going to be talking a little bit more about logarithms, and in particular we'll be talking about the change of base theorem. So let's get started. Okay, here's the first thing we want to talk about. We want to talk about the common log. So if you notice on your calculator, you should have a scientific calculator, you have two buttons. You have an LN button and an LOG button. The second key, or just above that button, is another color, and on the LOG button, so you have LOG, you have this button, and just above it in some other color you're going to have 10 to the something here. So the button log that you have and the second key is your tip off that is what the base is of the log button. So the common log, if there is nothing there and it just says log of x, that is understood to be a base of 10. So the only thing that your calculator does with that log button is with a base of 10. So that's why we have the fancy pants thing called change of base. We'll get there when we do that. But common log, I want you to know that if the nothing's there, automatic base 10. It's kind of like whenever you have 1 as a coefficient of x, you don't always write that 1 in there, but you have it understood that it's there. Same thing with logs. A common log, if nothing's there, understood base 10. Cool. Okay, then the other one that we have is called a natural logarithm. Now in your calculator, the button for natural logarithm is LN. So it's just kind of backwards of what you think. And then the second key to that is e to the some power. That is because if you're looking at natural log, e is the base of log. So anytime you see natural log, you need to be thinking e. So in the exponential section, you knew that e was a constant, so e to the x was a constant value of that 2.718 something something something, I can't remember. So it's kind of like, pi, where it's that constant value. E is the same thing for exponentials. So natural log and e are inverses of each other. So anytime you see natural log, you need to be thinking e, and your calculator also points that out to you by having it as the second key. Just the same thing as it helps you out with your log, knowing it's a base 10 because of the second key. All right, cool. Let's take a look at this. Okay, something that's important to mention at this point, remember we talked about inverses. And so in inverse here, if you have the natural log of e to the x, so the value inside the natural log is e to the x. Anytime you have natural log and e that are touching, they cancel out and simply leave you with an x. So anytime natural log and e are touching, they cancel each other out. Kind of like whenever you solve an equation and you have something like x plus 3 equals 4 or some crap, and you subtract 3 from both sides. Addition and subtraction cancel each other out. Natural log and e cancel each other out. That's what the inverses mean. Cool. By the same token, if you have e to the natural log of x, again, they are touching, so e and the natural log cancel out, and you're just left with your x. So that's something to keep in mind. Anytime e and natural log are touching, they cancel out. That's going to be a pretty important concept when we go to solve our equations with natural log. Or with e, you're looking at those, and natural log and e cancel each other out. So that's cool. The next thing that I want to say in regards to natural log is, remember all those properties that we learned whenever it comes to logarithms? Everything still applies to natural log. So anytime you have something that is natural log, you can still use the quotient, the product, and the power properties. Those three properties are all still fair game. Cool. Okay, so now we know those two fancy buttons on your calculator, that LOG and that LN button. However, how many problems have we worked so far that deal with log or natural log that are actually a base 10? Yeah, we're not doing that. So because base 10, even though it is the common log, you work a whole lot of problems out there that do not have a base 10. So in order to be able to use your calculator, we have what's called a change of base theorem. And here it is. Okay, here it is, the change of base theorem. If you have log base a of x, where a is anything other than base 10, then you can use your base 10 logarithm and do the log of x divided by log of a, or the exact same thing with your natural log button. Either one works there, that you're going to end up with the exact same answer. Now, even though either one of them works, my personal suggestion is to go with natural log, because whenever we solve equations in this next section, we're going to be using natural log all the time. So if you get used to using natural log and using that button, it'll just become more natural to you to use it there. However, either one of these do work. And this is change of base theorem is a formula that is on your formula sheet for your final exam. And you saw it on your midterm, but we hadn't gotten there yet. But it is on the final exam form, so that's something that you can look at there. Cool, let's try an example. Okay, let's take a look at this example. Log base 5 of 17. So in my calculator, I'm going to write natural log of 17 divided by the natural log of 5. The biggest error that I see with people on this problem is they need to make sure that you're putting your parentheses around your 17 and your parentheses, oops, that's a double, parentheses around the 5, so that your calculator knows that's where it ends. If you leave off this parenthesis, then it'll think that you're dividing all of that as this first natural log. So make sure whenever you're doing your problem that you keep just the single parenthesis back there. So that's a 17. And then you can do your work. So bloop, 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 plug all that in, and you end up with 1.7604. And I think in my math lab they want you to round to 3 decimal places, so this would actually end up with 1.760 as your final answer there. So, cool. You can go ahead and put in log if you want to. Now, I don't have a calculator app, so unfortunately I can't show you the keys to push in, but you can plug those in and make sure that you're coming with the same answer. You will. Now, think about what this actually means. 5 to what power is 17? So, x has to be between 1 and 2, because 5 to the first is 5 and 5 squared is 25, and then we know 17 is between those two numbers. So 1.76 makes good sense because 17 is closer to 25. So it's always good to go back and think, okay, what do I know about logarithms? Does this answer actually make sense? So that you know you put it into your calculator correctly. Pretty easy stuff, right? Cool. You can do this. Good luck with your homework.